Welcome. Thank you for braving the horrific weather out there to join us this evening. So terrible. We're really delighted that you're here. My name is Chris Schaefer, and I'm the Senior Associate Dean for External Relations at MIT Sloan. MIT Sloan is the one hosting this event this evening, but I know we also have a lot of MIT friends in the room as well. So delighted to have you here, and we're really happy to be here in New York. I want to start by thanking Brad Peterson, who's on the panel, but also hosted us here this evening. So thank you very much, Brad, for giving us this awesome, cool space. It's really great. So the Internet of Things is becoming increasingly a growing topic of conversation, both in the workplace and outside of it. In fact, we were hosting an event very similar to this in London last week, and I heard the expression IOE. It was not something I knew, so sitting in the front seat, I'm on my phone, and I learned it's the Internet of Everything. I think that is also a thing that I knew nothing about before last week. Regardless of your field of work, or if you're at home or in the city or considering smart, the Internet of Things not only has the potential to impact how we live, but also how we work. You may be thinking, what exactly is the Internet of Things, and how and what will the implications be for me and for society? We're excited to have that conversation with you tonight. I'm very pleased to introduce our featured speaker, Sanjay Sarma. He's the first Dean of Digital Learning at MIT, oversees MIT OpenCourseware and the development and use of digital technologies for MIT's teaching and the massive open online courses. He was one of the founders of Audio ID Center at MIT, which helped to develop the technical concepts and standards of modern RFID. Today, the suite of standards developed in the Audio ID Center are utilized by over 1,000 companies worldwide. Sanjay will open the program with an overview of the Internet of Things, and then will introduce us to the panel of IoT speakers and experts who will give you a first-hand glimpse into the impact of IoT has had and will have on all of us. Please join me in welcoming Sanjay.
Thank you, Chris. We had some instructions, and we're going to completely ignore them and do something different. I'm supposed to speak for 15 minutes. I won't. I'll speak for about 6 to 7 minutes, and then we'll introduce our panelists. I've asked them to say a few words, try and be provocative, and then we'll just go into discussion. We're hoping that this will be very sort of interactive. I maybe start with a very brief history. So in 1998, I was a colleague of mine, David Brock at MIT, came to me and said, Sanjay, we got to look at this stuff called RFID, radio frequency ID. We didn't invent RFID. It had been around for 50 years. And I remember starting to look at the technology, and we wondered why RFID tags at that time cost $20, $20. Even today, by the way, when you buy like a toll pass, like, you know, that horrible plastic box that keeps falling off your windshield. You're all New Yorkers. You don't drive. You don't know what I'm talking about, do you? Anyway, those toll passes cost $20. But the fact of the matter is, when you actually look inside it, we realize that the electronics there should not cost $20. And so we educated ourselves, and at one conference, I stood up and foolishly, it was foolish, I'm glad it was foolish, I said, these things should cost 10 cents. And there are a bunch of vendors in the room. Anyone here from Philips? No? Okay, all right. So, I'm going to insult a bunch of companies. Anyone from IBM? Okay, good. All right. I'm sorry. I'll hold back. Anyway, so a bunch of the vendors stood up and stormed out of the room, and we smelled blood. We knew something was on, and so we got into this technology. And what we did was we took all the data off the RFID tag. At that time, RFID tags, they used to put a lot of memory on them. And every time a tag got read by a reader, they'd store the data on the tag. So the tag needed a lot of memory, right? And so the tags became bigger. Now, RFID tags scavenged their power from the reader. But if the tags became bigger, as in they had more circuitry, they needed more power. That means the range dropped. And the range dropped, the number of applications that could use them became smaller. And so it became a sort of a cozy industry with a few applications like bus passes. So what we said was, forget that. Let's take all the data off the chip. Let's put only a license plate number on the chip. And let's put the data up there. And we didn't have the word cloud didn't exist at that time. So we used to say, in the sky. Okay, this is 1998, right? And people say, what the hell is that? And we go, it's the internet. And some people knew what the internet was. And they go, but how do you get the internet to a reader? And we'd say, and I'd hold up my Motorola, the defensive weapon that used to be our phone, right? I used to hold it up and say, trust me, one day that thing will be on the internet. And people thought we were nuts. And we were. But anyway, the point is that that's the standard we proposed. And it took some time, but eventually we won. The Walmarts, the Gillettes, the P&Gs sort of came to us and said, man, if you can make that work, that's big for the supply chain. In the end, we ended up with 100 supply sponsors. We generated standards. Last year, there were 10 billion RFID tags, give or take, with our standard on them. So, RFID started taking off. But around that time, people started asking us, why do you want to put RFID tags on inanimate things? Why do you want to connect things? And I had a colleague, one of the people I founded the Auto ID Center with, Kevin Ashton. He came from Procter & Gamble. And Kevin says, we should just turn it into a marketing slogan. So I said, what? He goes, let's call it the Internet of Things. Okay, I'm an engineer. I'm not from the Media Lab, all right? So, anyone here from the Media Lab? I'm just kidding. And I said, that's just a marketing slogan. I can't handle that. So I ignored it. But sort of like Steve Jobs' father, sort of recognizing Steve Jobs, years later, when it started becoming hot, I was like, yeah, we were sort of involved with that. But anyway, that industry is now taking off, and it is extraordinary. If you have any doubts about whether Internet of Things is going to change everything we do, right? This is a thought experiment I do, and if you've heard it before, I apologize, but the thought experiment is find a 10-year-old child, get the parents' permission first, and then ask them how that switch turns that light on. Okay? Just say, honey, how does that switch when I press it? How does the light come on? And I've done this experiment a few times. What do you think the child is going to say? Come on, what do you think? Anyone? Sir?
Yeah, just through the air, wirelessly.
Exactly. Okay, they'll say, Wi-Fi. Wi-Fi there, on. And you tell them, poor thing, you don't know how it works. That's not how we do it. We're adults. We have a wire, power comes in, it goes there, we break a circuit, the wire snakes through the wall and goes there, and then there's a ground that goes back in the earth, right? Who's right? Imagine if I had to move that 10 feet because the fire marshal says so. How much do you think it's going to cost you? $500, $1,000? Okay. How much would Wi-Fi cost you? $2? And what would the switch be? It would be on Velcro. Just pull it out, put it somewhere else, right? I mean, we do so many things backwards because we are in what I call frame inertia. We have a framework, and we are stuck in that framework, and that's how we look at the world, right? But the moment you can connect things in different ways, everything could change. Factories could change, plants could change, electric grids could change, everything could change. So it is not a matter of if it's going to happen, it's a matter of when. And by the way, the final thing I'll say is, if you think the Internet of Things is something in the future, don't kid yourself. You are in the Internet of Things right now. If you took an Uber, right, because you're New Yorkers, you don't actually own cars. If you took an Uber, your Uber car probably had, do you know how many computers? Anyone? How many computers does a car have? Yeah, between 50 and 100. Okay? Do you know how many sensors? Probably like 300 sensors. You are in the Internet of Things right now. It just often they're local networks, and maybe there's a connection to the global internet. But it's already happening. Every grid is connected. Pretty much every system in the world is connected. So that's what we'll talk about today. We have some really great panelists. I asked everyone to say one thing controversial, so I'll start with mine. So my controversial comment is this. I think we are plunging into the era of the Internet of Things without thinking it through. Okay, I'm Mr. Internet. I love it, right? I really want to do it. But everyone's doing it sort of willy-nilly and making it up as they go. So the first consultant, your daughter persuaded you, that you should replace the switch with Wi-Fi, you bring a consultant in, you might use Zigbee to connect that to that. Next consultant comes along and uses Bluetooth LE, okay? Both are sort of making up security protocols of their own, right? Someone else comes in and uses Wi-Fi. And then you need some sort of bridge. So you buy a bridge and you sort of cobble them together, right? Then someone wants to connect it from a cell phone. So you take it to the cloud using some made-up technique, right? We are setting ourselves up for a spaghetti approach, which will be hard to maintain and impossible to protect. And unfortunately, in fact, I wrote an article about this about 6 months ago, and shortly thereafter, there was the Wired magazine thing about a car getting hacked, right, remotely. I think, unfortunately, There'll be a couple of debacles before we wake up and smell the roses and figure out that we should have taken security seriously. So with that very charming, very sort of pleasant note, I'm going to now invite our panelists up. And so if Martha and Mike and Elio and Brad can come up, what I'm going to do is ask each of our panelists, please sit down, and I'm going to ask each of our panelists to come up and talk for about between 3 and 5 minutes, lightning round, who they are, what they do, and what's exciting about their lives, and one polemical point. So with that, we'll start with Elio.
Oh, really?
Yes.
So
You
the bar
sat
is
next to
here.
me, man.
Thank you. The bar is right here. No. So hi, everybody. My name is Elio. I'm the co-founder of Measurance. I've been in mobile technology all my career, really, from different angles. But this latest startup that I started last year, what we're trying to do is basically to build like a Google Analytics for physical spaces. The idea is that we built like an intelligence platform that through several sources, like sensors just like this. This is a normal like access point, one of those things that we buy at home to extend the coverage of the Wi-Fi network. What we do is that we remove the software inside, we put our own firmware, and so what we can do in a physical space like this, we can monitor and track like the number of devices, and so approximately like the number of people, where they are, where do they go. And so like in the retail environment, which is the first application that we have built, things like how many people go by the window, how many of those people stop at the window and then enter inside the store, where do they go to the cash register at the end, and things like this. And one of the challenges, I mean, we're trying to solve many challenges. One of them is to sell to retailers, as we thought, very difficult. Any retailer here? Very difficult. But so the idea is that one of the challenges is that, we collect a lot of data. And then the question is, when we sit down with this customer, is like, what do you do with this data? So it looks super interesting, but the so what of the data is extremely challenging. Internet of Things means really collecting a lot of data, and a lot of that data is simply not used. So I agree there are lots of challenges in privacy, in security, but one of the points is if we think that everything is going to work correctly, one of the big issues is like, what do we do with this data? Because we're approaching basically a situation where like the amount of data is clearly above like human consumption, and so one of the challenges is how do we deliver insights to people using the systems, and actually going beyond that, like how can we suggest actions so that like sensors can read what's going on, and then like an analytics or algorithm system in the background suggest insights or even actions that can improve what we do in retail or in factories or at home. So that was my provocation, I guess.
Terrific. No. So, Elio, let me ask you. So, it's sort of interesting when I listen to your description of what you do, both in your our earlier discussion and right now. It seems like it's not just about IoT. IoT is going to impact everything, right? It's going to impact GUIs. It's going to impact databases. The whole shebang, right?
Yeah.
What's your vision for that?
The user interface is huge. Like what we're seeing. So like we launched it's an early stage startup. So we launched the platform in January, and what we started from was a dashboard. And so the typical web-based dashboard. And so retailers were like, they were impressed, but, we saw that like after the first like couple of weeks, the consumption of that dashboard was decreasing. And then what we did was to, deploy like a basically notification system through like text messages. We built like an Apple Watch app. And the idea is that like what we are seeing is that people consume information through messages. And so that almost the UI now is like, or if you want, like the messaging apps are like the new browser. And so the UI is the messages that we exchange, and that's how people share information. Like one of the major sources of information for me is chats that I have with friends. WhatsApp is much bigger in Europe. I'm from Italy originally, so there everybody's on WhatsApp. And now we are sharing information like news articles and things over WhatsApp. And so that's how people are consuming on data on the consumer side, and I think that enterprise is learning to do that. One example is Slack. I don't know if you're familiar with Slack, but basically it's a chat application for which you basically reduce the amount of email that there is inside of a company because people are exchanging information. And that's how, like in the enterprise, we think, in retail, for instance, we have to deliver insights through like notification, text messages, app alerts, and stuff like this.
No, that's great. Thank you, Elio.
Yep.
So, it's interesting when the cell phone was first introduced. I was talking to one of the early pioneers in the cell phone industry. Apparently, one of the things that people used to resist cell phones was, why do I need a cell phone? I have a cordless phone. Think about that for a second, right? It's frame inertia. Once you have these new technologies,
what a
it's sort of
cordless phone is.
That's true. All right, so I'm actually going to go to Mike next because Mike, it's sort of a nice continuum from what Elio said. And Mike, who's also a professor at Princeton, is now on leave doing his startup. Maybe you can talk about IOBeam and don't forget to say something provocative.
Sure.
I think I know what you're going to say.
Mike Friedman, like Sanjay mentioned, I actually wear two hats. I'm a professor of computer science at Princeton, but thankfully one of the perks of this type of job is you can go on multi-year leaves and kind of pursue something entrepreneurial like you did too. So we have a company here in New York City called IOBeam. IOBeam is building a data analysis platform for the Internet of Things. So if you follow kind of Gartner, I think IoT is peak hype right now, but if you look back a couple of years, you probably heard the term big data as all the rage of the last 10 years. So the one question you might ask is, why do we need a new type of platform like our company's building for IoT? Isn't this all part of the big data revolution? And one of the interesting things is, for the most part, if you look at all the technologies and tools that basically people have been building over the last 10 years, these have largely been looking at data at rest. This is the type of analysis you do is large batch jobs. The data basically gets born, lives, and dies all in a data center. For perhaps non-technical people, data centers where Google is, where the cloud actually is. It's a warehouse. It probably burns maybe 30 megawatts. It has maybe 100 to 1 million servers inside of it. And they're amazing pieces of engineering, but they have great low latencies. And something like NASDAQ is you're optimizing low latency and multi-microsecond round trip times. Lots of amazing optimizations, but if you think about IoT now, we're generating our data near the edge. And so what that has meant is that we have intermittent connectivity, data gets delayed, you actually have clock misalignments between different devices. And so if you actually want to do the type of real-time analysis, not even at NASDAQ speed, but even at millisecond or 100 millisecond speed, or even sometimes seconds, you actually have to think about different type of infrastructure, where that if you enable basically data scientists, engineers to write code to analyze data quickly, you want to let them focus on their problem and not worrying basically about data management and how I deal with different abstractions and different problems due to my infrastructure, as opposed to focusing on my actual problem. So our company, perhaps a long introduction, our company is basically building an analysis platform that makes it very easy to collect, store, analyze, aggregate data, and basically allow people to focus on solving their data science problems and not worrying about infrastructure. Now, wearing my kind of two hats, one thing you hear a lot about in IoT is concerns about, Sanjay mentioned, security. A common thing is privacy. All these devices around us, they're going to spy on us. And this is what you hear all through the popular press, and what a lot of academic research also focuses on. So the interesting thing is, this is actually something, my controversial thing is, I'm less concerned about privacy when people think about all these devices being connected, because I think that the reason we're in this stage is actually the business models that arose around our data. And so when we were on web and mobile, because none of these things were physical, people very quickly expected them to be free, because they arose out of basically the advertising ecosystem, that you could get these free, the contract that we made with Google and Facebook is, we'll get these great services for free, you'll just be able to monetize our data. Now, the interesting thing is, when we turn to IoT, when people are talking about often deploying physical resources, that probably is going to involve actually people buying those hardware devices, then paying service contracts for those devices. So I think actually where problems are perhaps cannot be solved by technical solutions, or technical solutions are hard, they're actually going to be solved by more kind of the economics of the transaction. At least that's what I hope.
That's great. So, by the way, if you look at databases and how IoT streaming data is processed, there have been a bunch of companies like Streambase and
Sure.
LogMeIn. I'm actually an advisor of LogMeIn, disclosure. Right, I'm just curious where they all fit
Stream-based
in.
MIT company.
Yeah, stream-based MIT. I only talk about MIT companies, by the way.
Awesome. Freddie's a
Yeah, there's a whole
graduate,
bunch, yeah. So, I mean, what's the landscape?
So I'm going to, so we have, one of the secrets about academia is that we're also, we think, of course, higher of our own area than our other areas, other subdisciplines.
We're contemptuous.
We're very contemptuous, yeah. So my background is in systems. I'm not a database person. So the interesting thing, I think, if you look at actually how a lot of these ecosystems arose, is the database community became very focused on industrial problems with relational data. And so if you look at actually where most of the problems of scaling, they really came out of the systems community. We're going to take credit for that. Because they actually didn't have to solve the problems of IBMs and insurance companies like Oracle. And so if you actually look at Streambase, so my understanding with Streambase, where they actually ended up making a lot of their money was actually in the financial trading market.
That's right.
Was because their model was, there's great ticket prices to sell it to these companies, but their scale, they're taking their database hat and the consistency guarantees they want are like 5 or 10 servers.
Right.
And now we want to take to a model like how do we actually build scalable infrastructure that you could run. You could actually have a person like IOBeam, you could actually have an engineer write a 100-line piece of code, and transparent to them, we could run this thing on 1,000 servers and make it scale over that size. And so I think one of the differences is that there's a new take on scalability that really lagged the data infrastructure sector. They didn't think of scale in the same way because they were still selling to big iron. And now it's all about, at least in the non-sub-microsecond area, it's all about scaling out and how you could actually do large volumes.
Got it. So smaller pieces, much more highly
Yeah,
scaled, right?
and reliability through software, not hardware.
Got it. That's great. Thanks. So Martha is one of the founders of a company called What's On, said with an Australian accent, I believe.
Yes.
Right. So why don't you tell us about What's On, and don't forget the controversial thing.
Thanks. So I'm Martha Amram, CEO and founder of What's On. One of my co-founders, also an MIT grad, is Australian. So that's why we're talking about What's On. That's our name. Anyhow, we help people save energy and money. We started before it was really obvious that the Internet of Things was going to do something in the home. So we know a lot about energy savings. I know how to help you save energy through habits, what to buy. We have all that pulled together. And we don't sell to utilities. We try to make it happen for community programs and other places, managed properties. What's happened in the last 3 years is we realized that the data for running all this is captive in the utilities. Like, can you get your utility bill data? Can you see your usage? If you have a smart meter, can you see your usage? If you don't, and you have monthly data. So only about 40% of American homes right now have smart meters. And of those that have smart meters installed, the utilities have only implemented maybe 12 or 15 million that are really pushing out 15-minute granularity 2 days later. That's what the best smart meter does right now. So there's a whole layer of how do we get data to be an energy smart home, and that's where my company comes in. We have built software tools that consumers use. They permission us to go get their data from their utility company and bring it back. And so we have a national platform for this. We do it in a couple different ways. So we're liberating the utility data layer. And then on top of that, we put back on all of our energy analytics because we do know how to help people save, and we have a lot of street cred on that. We usually save people about $20 a month. And so if you think of who needs that besides the utilities, it's this whole clean tech ecosystem. The solar guys, the thermostats, and the home energy monitors and the home energy efficiency type, let me retrofit your house companies need all this data. So that's who we're selling to right now. And just to think about the Internet of Things and how this comes together, the solar is an inverter on the roof, and it goes to the cloud, and it comes down, and then we can show it on a mobile phone app. So that seems pretty easy. And let's say you wanted to know how to save, wanted to see your savings on solar. Like, is it really saving me money? Not one solar company right now has solved that problem, and that's our market, because we're matching the utility bill data to the solar data and doing the little calculations that say, yes, you saved, and no, you didn't. The utilities are not helping this, and okay, is anybody here from a utility? But the utilities are not helping this because, for example, in California, if you have solar on your roof, they only show you your net consumption, like what you did after the solar took its bit out. And so how can you tell if you're saving? And so there's a market for a company like us to put the data together with this very simple application. Another thing that we do is integrate with thermostats and show, is the Nest thermostat saving you money or not? That's kind of a hypothetical because Nest won't allow companies like us to integrate, which is a little less open on the Internet of Things than you'd like. So there's other thermostat companies that we've integrated with. And then the third one is a home energy monitor. Because of the stall and the smart meters, and because they're not real time, they deliver data 2 days later. There are companies out there selling, 1-minute interval data, 5-minute interval data, see if the lights go on in your house, see what's going on. And so we integrate that in as well. And so there's a whole data layer here that's being assembled. And then the question is user engagement, energy savings, how to make my home smart, and also the willingness to buy. Am I a good candidate for any of these things? What will it mean to me? Which one should I buy first? So that's sort of the smart energy home, and that's where we play. My provocative statement is changing, because you talked about putting Velcro over here. And let me tell you what the state of the world is with energy. It's not. We're really wired in. So Nest thermostats had a real snafu in the polar vortex about 2 years ago in Chicago, for example. The furnaces had to run 24/7 to keep the house warm. And Nest is running on a battery, and in traditional, Apple design, even though it's not an Apple company, it was an entirely closed form factor. So running, battery drawn down. Oh my God, my heat's gone off because my battery died in my thermostat. What am I going to do? Rip it off the wall, send it to Cupertino, California? Yeah, right. And so there was this sudden realization that you can't do just a battery alone to power a thermostat because of the variance in weather. So the alternate model means you have to actually run a wire, it's known as a C-wire, from your furnace all the way over to your thermostat, and that's what's powering the thermostat. Okay, now we have an installation issue, we can't move it around, all those kind of things. So I point this out to say that the Internet of Things in the house really does still need a lot of wiring, at least that part about energy. And then I also point out that there's a great business opportunity in home energy monitors. Right now they're snapping on circuit breaker panels and then fitting into the actual circuits. Okay, that's an electrician call. About a third of circuit breaker boxes don't meet code and are actually dangerous to open, so there's a huge liability. Ways in which we can get those kinds of data from the thermostat or make the thermostat run without the wiring, or make the home energy monitor not need to get inside the panel but be on the outside. Those are hardware opportunities that then create the opportunity for companies like mine to integrate the data. And I think there's some real hardware opportunities out there in making the connected home. And it's just not as simple as Velcro.
I agree. Well, thank you. So, quick question about dynamic pricing. Are we going to have to watch our pricing on a second-by-second basis? Is this what's going to happen?
So, right now, less than 1% of Americans have what's known as time-of-use pricing. And only 2 utilities actually show their residents their data in real time. That's Chattanooga, Tennessee, and Oklahoma Gas and Electric. So other than that, nobody else can see their data real time. In California, the regulators have said they're going to have time-of-use pricing in residential by the end of 2019. And what that means is blocks of time will have different prices. From 6 a.m. till 2 p.m., pretty low price. From 2 p.m. till 6 p.m., very high price, and from 6 p.m. to midnight, it starts going down again, and then weekends lower and nights plan. So within those time periods, we'll have price signals, but consumers will be very confused. So the sense is, what's the insight, back to what you were saying, that you can draw out and show someone, just do this one thing, that will save you money.
Got it. Thank you. So I can imagine a dryer, that negotiates with the power company and picks the time to do the drying, right? I can imagine doing that just before, a camping trip, and I need clothes, and the dryer sort of having a conversation. I'm trying to hurry up. It'd be hilarious. Which leads right to Brad's presentation.
Well, thank you. I think there's a benefit to going last.
So I mean, it's sort of interesting, right? I'm a hardware guy, hardware, software. Helios talked about hardware, right? You talked about data, and now we're going to talk about something that has to do with taking the data and looking at pricing.
Decisioning on it. So I'm going to start then with my provocative statement.
Please do.
Because I think you gave me a great lead-in. I think with all this data, with all these sensors, with all these connected devices, more of our experiences in our life is going to be dynamically priced, not fixed price. So that's going to be my starting point. And I think this is a great opportunity, certainly for people that come from MIT and have the skills at optimization. So much waste we have in our society when you look around. And economics, supply and demand, if we took Uber tonight, I had to pay 2.5. What did you pay?
2.9.
2.9. So the reason why I still got serviced and got here on time is because they jacked up the price, the demand went away, and I was coming here because I was on stage, so I was going to pay, so were you, we were going to pay the higher price. So some people don't like that. We talked, and maybe this is the provocative thing, I don't think people like in our society a lot of things being dynamic priced, but I think power is going to be dynamic priced, our transportation is going to be dynamically priced, and that's a good thing. I think it's a much better way to manage scarce resources. So the interesting thing, I'll back up a little bit. I run global technology for NASDAQ, so welcome to our home here, and I'll give you a tour later. It's a very exciting place, and we had 3 IPOs here today and 4 tomorrow. So the IPO market is open. If you guys get to that point, we'll take you out tomorrow. So I worked at eBay before, and the eBay platform was built flexibly to sell anything that ever existed on Earth. So it's really phenomenal. You know, it was also, you know, basically putting in the cloud swap meets and garage sales, which isn't that compelling, but incredible reuse and sustainability. We never really got that message at the time, but if you think about it, rather than throwing things away, people actually sold them. So I came to NASDAQ and I looked at the technology we had, and I said, I wish I'd done it the other way around, because there might not have ever been an eBay. So financial services does, you know, this is what we do, and we do it really fast, and we do it at high speeds. And if you think about it, we do price discovery. We make markets. We handle massive amounts of data to figure out what the price should be. And eBay went out and said, we're going to do that. We won't do that for financial services because it's regulated, but let's do it for the rest of the world. Well, that's a bigger market than financial services. So in a lot of ways, having seen that experience, I'm observing that today we trade stocks in microseconds, and then we hurry up and wait 3 days to clear it and settle it. And it's really amazing. And that was all the 1970s to get rid of paper. So as we think about all these great things and all the data that's going to be available, decisions are going to be able to be made much, much quicker when you have connected devices. There's a missing piece. So think about our payment system. Think about how quickly you can clear a transaction. If 2 devices want to make a decision and negotiate scarce resources, and there's no people involved to swipe a credit card, or Stripe went out today. That's not very forward-looking. That's kind of like a backward. They went out quickly, and on NYC, by the way. They went out quickly because they're probably really outdated already.
MIT company, by the way, so be careful, what you say.
Did I say Stripe?
Yeah.
No, I didn't mean Stripe. I meant
Square. You meant Square.
Stripe's
yeah.
a great company, yes.
Thank you.
Collison Brothers are great. Square went out today. They're backward. They're done.
And they had a good bump as well, right?
What?
They went up right after.
Yeah, because they priced it at 9. And its value was 18, I think, before last week. So you really need a reinvention of this type of very high-speed micropayment system. So I think there's a lot of innovation, and you couple that together, all the sensors. You know, I think you were right at the forefront. All the opportunity to really start to dynamically price, and then the decisioning platforms that are coming. There's going to be an innovation in payments as well. So we're excited about taking some of the technology and things we do and pointing it and not missing an opportunity this time.
So what are some examples? We talked about taxis, we talked about electricity. What are the other things that can be completely dynamically priced? What are the things I need to go look and, before I do something, figure out what the surge pricing is?
Well, I think there's everything you have, if you connect it, there's going to be some better time to actually conduct that. If you're a business, I think a lot of the businesses are going to be the first ones where you say, do I need to pay the premium price right now to deliver my goods.
Parking, you
somewhere.
talked about parking.
Yeah,
right?
and parking's a great one. It's statically priced in a place like New York City. When the Knicks are playing, you should have, a couple miles around Madison Square Garden. Dynamically priced. If you're up in Boston, they have Park Boston.
Yep.
Now it's great. You're sitting there, it's raining, and you just have the little number and you can park. Well, you look at that. Park Boston already has the infrastructure. Now all you need to do is have them start to change the price on you. So I think as you start to look at it that way, when you said when am I going to dry my clothes, right?
Right.
I really think you can optimize a lot of your power consumption, probably more in a factory and a business than in the home, because big companies and data centers do this already. So you see it in a data center where virtualization, being able to spin things up, spin it down, versus run everything all the time, when we know our business is not running flatline their peaks. So I think wherever there's peaks, there's an opportunity for optimization.
And it'll smooth it out.
Yeah.
It's sort of interesting. I heard an interesting statistic the other day. Apparently in 2014, before Uber in San Francisco, taxi revenues were like $200 million. And after Uber, taxi revenues dropped to $120 million. Okay, surprise, shock. Not good for the taxi industry. Do you know what Uber revenues were in San Francisco?
$500 million.
Yeah, it's actually well in excess of that. It was like more than 500, right? So let's say it's I've forgotten the number. Let's say it's 500. So it's 500 plus 120 for taxis if you count Uber as taxis. That means total taxi revenue went from 200 to 600. Well, guess who lost out? The car companies that are trying to sell cars.
Yep.
Right? The insurance companies.
Cars are used, I think, an average of less than 10% of the time.
Yeah.
So, and
Right.
50% of LA is the land is for parking
For
cars.
parking. So, the thing is that
Yeah.
resource sharing that the Internet of Things will enable, I personally believe will have profound implications on the landscape, the economic landscape that we're used to. So with that, we should open it up for questions. I have a question for the crowd as we get warm, for the panel as we get warmed up. So I guess one question is, of all the things we take for granted, internet, all the utilities we take for granted, which is the first one that is going to change? Is it internet? Is it networking? Is it water? Is it power? Is it transportation? What is it? What do you think?
I think businesses are going to drive this more than, we talked earlier about I was sharing the story about my dad being very excited about him being able to monitor his home from his smartphone. But I think the businesses are going to be actually the ones driving the market. Because also I think that if you think about how many super cool and sophisticated software we have in our hands as consumers, right? So Facebook apps and our phone itself. Businesses and enterprises been lagging behind in a way. That's, in retail, you have all of these devices that become obsolete immediately, and then instead, the update about mobile devices is constant for consumers. So I think that there is a paradigm shift in business that is gonna push them to adopt this much quicker.
But businesses are stodgy. Sorry. Consumers are fast, right? Consumers bought Nest, although apparently it's flattened out, right?
Yeah, I would say that, a saying in the solar industry is that solar is sold, not bought. And, 75% of solar is sold at a kitchen table in a face-to-face conversation. So they could have a big data tool to kind of shape a proposal and so on, but there's still this human moment. And that is really true with everything that's complex in the home, security systems, drop cams, all of this. So we like the gadgets, but we have to be concierged, if that's a verb, through it. And so I think it will not be in the consumer sector first.
Is that right? Okay. What do you think?
So, I would agree with that. I think the interesting thing is that with Metcalf, I forget, an MIT.
Bob Metcalf, yeah.
Yeah. So we talked about network effect, that networks become powerful. Often the value of them grows with the square of the number of nodes that are connected to it. And I think that people talk about the value of the internet being that good, the value of Facebook, of WhatsApp. As your more friends are on it, that's true. So I think the similar thing is happening actually with internet-connected things, that the reason why cities and large enterprises are able to get more value from them is they could actually make decisions and and do things at scale that aren't as interesting for an individual consumer. I talked with, for example, so Princeton, is a small town. It's sometimes like universities. We own our own power generation, cogen. It has about on the order of 500,000 light bulbs. So if you think about just the logistics of changing light bulbs, is that somebody has to know it, you put in a work order, you call somebody in facilities, the next morning he gets a work order to go put out the facilities. And so the reason you see adoption of a lot of IoT is in industry is they do things like predictive analytics. So you have companies that actually look at, for example, in power, they look at the power draw of devices, and they actually have a model of what correct power draw should look like. And these things behave strangely when they start having errors. Or you look at vibration models. And then you could actually look at an entire city and actually know when things are about to go bad. And then you actually, know all the places where things might go bad. And then you actually could plan past, much like FedEx decides how to route packages, you could decide how you route your workers around the city to change light bulbs even before they go off. And so there are actually these scales, I think, that are going to happen in enterprise that they'll be, you'll be able to turn your light bulb off your phone. I just think it's a lot less exciting than the things that we're actually going to see in cities and at large scales.
Can we get, if there are any questions? So we have a question. Actually, Brad, your quick
No, I'm
comment on
fine.
that?
Let's
Yeah?
take a
Okay,
question
all right.
and I can.
There's a lady there with mine. We'll come back to you, yeah.
Hi, so I'm a tech journalist. I've been covering IoT pretty much since its inception. And one of the things that's so prohibitive for people to adopt it, the average user, are all these conflicting protocols. People just don't understand how to make one work with the other. I spoke with the heads of the Wi-Fi Alliance last year. Their consensus seems to be that Wi-Fi will be the definitive way to connect all these devices. Do you feel, in the panel, do you feel that Zigbee, Z-Wave, Bluetooth will pretty much go away and it'll be Wi-Fi? That's my one question. My second one is for the gentleman right there in the glasses. Yes, yeah. You seem
Only
to
with glasses.
you seem to
The
infer
Princeton
that
professor.
you seem to infer that people will adopt IoT because it's free and cheap and there are some benefits. But we keep seeing these security breaches, and at what if you have a smart device and you're giving your credit card and your information to a service provider, there's still some risk. And we keep seeing all of these hacks and these data security breaches. Do you think there's some ethical responsibility for investors, venture capitalists, researchers, and all these people making these things to really assure people that, or to tell people that it's not quite secure yet?
So two questions. One is, will Wi-Fi be the one ring that rules them all? And the second is security. By the way, my quick answer on Wi-Fi is that if you have things with batteries, you need one protocol. If you have things without batteries, if they're powered, you can use another protocol. If some devices produce a lot of data, like a camera, you might need a different protocol. If it's just a thermostat, you may benefit from using a very low power protocol. So my view is there will be, unfortunately, a proliferation of protocols, number one. And number two, we didn't react fast enough. So these standards, we have too many standards in their set. So my view is give up on that. Just make sure you go securely from here to the cloud and connect things in the cloud. So that's my philosophical sort of, and that's what Nest is doing. You connect up in the cloud, you don't connect locally, right? So that's my personal view. But folks?
Well, in my company, in the last couple of years, beacons companies, like BLE,
Yeah.
Bluetooth, Solo Energy, it's been very hyped up concept because Apple invested in it.
beacons, yeah.
Beacons. And so every meeting with an investor is like, are you a beacon company? It's not like we have to explain that. No, it's like we use Wi-Fi. So, we are very agnostic actually about technology. We're going to use whatever technology is mostly available. And Wi-Fi right now, most of us have Wi-Fi on our phones. They're very open and it's easy, and they're bi-directional. So while Bluetooth is basically the beacon, it's one directional. So, but I think that you have to be a little bit agnostic in that sense. That we're going to use the best technology available with the least friction. Because another problem with Bluetooth is that you have to have Bluetooth on, which is very rare in most devices, and then also you have to have an app that interacts with that device. So I think Wi-Fi is a great. We started from Wi-Fi because of its great availability, but we're thinking about video. With the same perspective, no? So low-cost, like commodity devices that are powered by software. And that's also like another thing, which I think like moving away from the hardware, and everything is going to be software really, and the hardware is basically.
So abstract the hardware, go
Yeah.
to software, right? Mike, about the responsibility on security.
Sure. So
I think there was more security, not privacy.
Yeah. So the first quick response to your question, I would completely agree with Sanjay. I mean, these technologies, radio technologies, are actually different. They have a different purpose. They have different range, transmission capacity, power consumption. So you're going to continue to see the use and proliferation of multiple ones. If you are tracking moose in northern Canada, you are not going to speak Wi-Fi. You're going to speak like 2G, long-range cellular bouncing off the ionosphere. If you're a little radio frequency device, so that's going to be driven by what the technology needs and the energy consumptions of those different technologies. I actually didn't say that. What I actually said, I think, was maybe a slightly different. I'm sorry if it didn't make it clear. What I actually commented about privacy was I was actually less concerned about privacy because they wouldn't be free. And I think one of the reasons why we have so many privacy concerns on the web and mobile is that we want our content free. And so we actually pay for it with information. And so if we are buying physical devices, we will often, there'll be less, people will be less mining our data and selling it, reselling it to make up money. Now, you're asking about security, which is a different question. And so then it's really a question about commission versus omission. And the concerns about privacy are ones about commission. Are they actually selling our data? The concerns about security are really about omission. Do we have companies who take it seriously and take security seriously? I think what happens is partly security is this hard thing because it's very hard to evaluate from an ROI perspective. And so this is why also investors have largely hated selling to security companies because people don't want to buy this until they have breaches. And how you actually value the amount of money that you put into security. I think it will take one of the problems that we've had in this traditional IoT ecosystem is these were largely old hardware companies that were not used to building software. A lot of their technologies were built just like with the internet. The internet was not built with security in mind. Perhaps this is some of the problems. In the 1970s, when the internet was created, there was no security built at the core. And so a lot of our infrastructure is unsecured. And I think it really comes down to new companies and the existing companies taking it. There's not any hidden stories here. I think we know a lot of best efforts to do. Hacks will continue to happen, but we actually also rely on our financial services and credit card companies to handle fraud via again business solutions for this. We are not responsible for fraud in our names with our credit cards. This is why we use credit cards. I think so. This requires both technological solutions, and it requires that the business mechanisms are in place to make sure that you pass on the right risks to different parties. But I think it is a concern. But I think we should. It's companies that have shown their willingness to actually operate well and be good players, and they will be recognized as such.
So, yeah, go ahead, sir.
So question so the Internet of Things means to me all things have to be accessible to the Internet. And it's not clear to me that everything is even close. So I guess my question is what percentage of the things do you think we have? I'm thinking in the house, for instance. It's one thing for me to know that my lights are on, but I don't need an app to tell me my lights are on or off, right?
Right.
But I don't know if the appliances in my house are dynamically turning on and off to be able to optimize my electricity consumption. I mean, the app will tell you what I'm using, but I really need to control it. And in order for that to happen, I've got to have something wired to turn off to be able to communicate. And I'm not sure. I mean, it seems to me like I'd have to replace the entire house to do that. I mean, factories, businesses, I think, are getting there. A lot of machines and tools are, at least they have IP addresses, whether or not they have power consumption,
So maybe
programming
you want to take a stab at
So
that?
I totally agree with you that the house is not very wired up for the Internet of Things. And the pecking order of what consumers are buying is security, burglary prevention, like the first one being alarm going off if something happens, incidents. The second one, prevention. The third one, the cameras, like the drop cam for the porch, that's pretty popular. Now we're down to health monitoring, like grandma wearing a tag and having that connect to the internet, and then energy. So you can sort of see that none of those require a whole house. And then there's just this sense that if we shift things around, it's going to be meaningful to the consumer for energy consumption. So do you really care when you're going to go camping that you could save 25 cents by shifting your dryer load to a different time? That's the size of the price signals we're going to be sending with dynamic pricing, however we call it. And at the same time, utility revenues are starting to fall because natural gas prices are going down, oil prices going down, and leading to a cascade of energy falling. Thus, you get cheaper and cheaper electricity pricing, more expensive grid. The grid doesn't care when you use stuff. And so we're just going to see a whole bunch of different changes in the price signal that say to me, we're not going to have the Internet of Things all over the house to manage energy. It's going to stop pretty soon from storage plus solar plus thermostats.
Unless Brad has his way, right?
Well, it's not just the home. I think it's
everything.
I would say I'm a big fan of transportation, and living in the Bay Area and fighting the roads there, and then moving to New York City and seeing you could dissolve with the right information signals traffic jams and the mess you have in New York City. So, it's not going to be that popular. We've got to figure out a social way to make it, economically accepted, because it probably will not be viewed as fair. There's one way, if you just do it on price, it's going to not be fair. But I take the subway, I take Uber, and I make dynamic pricing decisions, every day. So I think New York City could be run so much better. If you look at Waze, if you haven't used Waze, it's amazing. You get the sensor in your cell phone, and the driver driving around in Ubers usually got Waze on, and it's amazingly accurate. But the next step is to actually take action on it. And I think there's huge amounts. So transportation, in my mind, is one, and that translates back into productivity for all of us.
I wonder if we can buy a traffic signal. You're driving, and the traffic signal's turning against you. You just buy it. Buy the green light,
Well,
I want the green light.
yeah, they had the commercial, it's Bob's day, right? And all the traffic signals are going his way.
Comes free with the Ferrari. The green.
There's a lot of work for economists and
Right.
social science to figure out what is the right mix of how you implement it. But the technology is going to be there before we're ready to probably accept some of the solutions.
That's right. I like the expression, dissolve a traffic jam with information.
Yeah.
That's a very beautiful expression. So we have, I think, time for one more question. It's there. I'm sorry, I'm following orders here.
I have a quick question on reliability and predictability. I have some smart things in my house. I have a cell phone. My biggest issue is when power goes out at the house, when the cell tower goes down at the house, when the Wi-Fi goes out at the house, all those devices are useless. When I want to get Uber and I can't get a signal, it's useless. So to some extent, this is all great, but what happens is when times get tough, when there's a lot of people looking for something, the whole system breaks down.
Well, I just want to tell you that as I was walking here, my cell phone died. And I had no idea what to do. I was looking for quarters I could.
So in that case, you take the subway and there's no surge pricing, it's $2.75.
Geez, I mean, I was a babe in the woods. Anyway, so.
That's great.
So what do you think about reliability?
Well,
What's the implication of reliability? Is the whole world going to come crashing when when there's a bug in iOS or something?
Well, the world is imperfect, so yeah, I think it's going to happen. And we are always very worried that the sensors are up and they're pushing information, and stuff happens definitely. And I think one of the things that you touched on that, which I think was interesting, which is a lot of the inefficiencies are actually not priced, and people do not have that quick math in their mind, and then maybe dynamic pricing is this is how much it costs. This is being late for a meeting. Maybe it doesn't have an immediate cost, but it might,
right.
And you can price it. And so I think, I think that this is, for instance, one of the roles of the government. Internet connectivity is essential for the Internet of Things. And so if you think about developing countries and even in remote corners of the nation. I mean, I think it's very important that internet is up. I mean, it's now as essential as electricity.
So I'll say some things. I think reliability, people have to be willing to pay for it. And there's industries that have done it better than others. And likely, as people move from different industry, they'll take those techniques and apply them. But if you think about the difference between life and death, we will absolutely be willing to pay for high reliability when it has to do with human lives. I think things like, every day I live with the stock market, but if the stock market is really not up, it's down Saturdays and Sundays, and it's down right now. So, the news loves to make it a big deal, because it sells negative news. But in the end, stock market's down, we're all fine right now. So I think, we may be better off. No, we're not better off. So I think every industry thinks it's the most important, but I think the ones that really cater to life and death are the most important ones. And I think the telecom industry was one of the best at engineering high reliability. If you think about what AT&T was able to do, and if you look at some of the techniques for high availability of switches, this phone system didn't go down. And a lot of the new companies are actually just taking those concepts and replaying them. So the solutions are out there. It's just not every industry applies them because people won't pay for it.
So I think Martha and Mike have the last word, because we're coming to the end of time.
I was just going to comment that the word reliability gets clothed into business practices. So a question for the smart grid in California right now is, should the state be one mathematical optimization problem with many sensors at all the corners and so on, feeding up who's producing solar, who's consuming electricity, to a master dynamic pricing model? Or should there be sub-models that are self-contained and then all over the state and then rolled up? The utilities are trying to get the sub-model thing in place because they say, quote unquote, it's more resilient. After all, look at Hurricane Sandy in New York. We need this kind of resiliency out in California. And what it is preventing price discovery in the stock market sense because it's sub-optimized. And so resiliency takes on a business practices connotation.
Right. That's right.
So a couple things I want to say. So first of all, I think there's an old system engineering practice called fail-safe, which means that when your system basically is bad conditions, you want to revert to some conditions that's safe. So in the case of what happens if my cell phone doesn't work, should Uber, self-driving cars are going to do this? What is the state? What is the condition they're going to revert to when they lose information? So you have to think that when engineering products that you want them to revert to a safe state, and that's one way that in case things go out, all of a sudden your smart stove doesn't just open the gas and not turn on the fire, that kind of thing. In terms of reliability, there's two things. I think Brad made the great point about paying for it. So the way space shuttles used to work is they had this thing called triple modular redundancy. You actually bought 3 physical switches that they put. So it cost you 3 times as much as before, but they actually took a vote, and they looked to make sure that at least 2 things agreed with something, and that's the decision they made. So if you think that you engineered, you paid 3 times more, but you got some redundancy. Now, we actually saw this happen about 10 years ago in software. So a lot of software companies started adopting basically, this again goes to my kind of academic groups, protocols that are called consensus algorithms. Actually, a lot of them pioneered at MIT by somebody who just won the Turing Award,
right.
Institute Professor Barbara Liskov. And so they would actually have computer systems that would vote with one another and see if they agree. And you actually see this at the core of what runs Google's and Facebook's, whatever. They actually now run voting algorithms to make decisions. Now, the one thing I would like to say, however, about Brad, about the telcos, so you can look at the telcos and say they were highly reliable. But remember, again, about paying for it, every 9 of reliability, you're basically going to pay an extra order of magnitude of cost. So if you want 1 minute of downtime rather than an hour of downtime a year, it's going to cost you probably 10 times more. And so the question is then it becomes very expensive hardware, which also limits the amount that you're able to innovate. So one of the reasons we actually have bad cell phone service is the telcos still haven't figured out that they actually shouldn't build as reliable systems as they want to. Because the way the internet actually prevents everybody from overloading it is networking basically use the sign of congestion to tell people not to stop sending traffic. Right. This is called congestion control. And this was invented in the internet in the 1970s, right? And the way you determine something's full is you start dropping packets. Now you go to the telcos, you say, What happens when you overload it? Just throw away data. And no telco would stand for this. So what the telco has built is they built longer and longer buffers so they never drop packets because that means you're more reliable. Except it's actually not now giving a price signal to the edge that says the network's overloaded and you should back off. And the reason why your phone sometimes takes a second to communicate round trip times is because the telcos don't want to drop your data because they think that's how you're reliable. So you have to be careful about throwing away reliability because you could solve these problems on different layers. And I think one of the most interesting things is we've turned from solving them at like hardware reliability piecemeal to kind of pushing back the smarts to the edge and allowing us to deal with a little bit of chaos, but kind of building a much more efficient network.
So someday we'll get a little electric shock if, some sort of negative signal. Well,
Congestion pricing.
price signal. Unfortunately, we're at the end of our lightning round presentation. I'll just maybe close with this thought on reliability. It's not a very cheerful thought, but I think if there is a war, the next war will not start with a missile. It will start with one country taking out the other country's infrastructure. And it's already happened, actually, with something called Stuxnet, which some of you know took down some of the utilities in Iran. And there's some guesses as to which countries were involved in that. But with that, I'd like to thank the panelists. I think it was an exhilarating and quick and very enriching debate. So thank you very much.